So LASSIE stands for Legged Autonomous Surface Science in Analog Environment. The project integrates technology, which is the legged robot mobility and sensing, along with human-inspired autonomy to enhance future exploration of planetary surfaces. What's unique about LASSIE is that we are developing legged rovers that can use each of its legs as a scientific instrumentation. For legged beings like us or animals, every step that we make, we can actually feel from our legs whether the sand is soft or more rigid, and whether it might be crunchy, like there might be having water ice in it, or maybe that's compliant. These information would be very valuable for our planetary scientists to know so that they can infer what the environment might be and what leads to the involvement of the environment. So we are developing this called sensing during locomotion capability for our legged robots, such that when we send them to the moon or the Mars, they can feel the ground through every step when they walk. So they can report to the scientist the property of the terrain. So Spirit is our quadrupedal robot that each of its legs can be used as a terrain sensor. So Spirit can walk in a variety of different ways, just like we do. First of all, it can walk at different speed. It can quickly scouting over a large area to report where the sand is soft or rigid so that we can, for example, decide where to build houses and where the rover can traverse. It can also walk slowly and carefully place a leg into the sand. And while it penetrates into the sand, it can feel whether there's surface crust, where there might be surface ice, and what's the heterogeneity in the sand. So this information will be critical to relate to the composition of the terrain so that our planetary scientists can use this data to inform how the environment get to the state it currently is at. Sand is extremely challenging for humans or robots to move on. One of the reasons for that is sand can behave fluid-like or solid-like. And it's very tricky to predict when it will start to flow underneath the feet. So one thing that Spirit does extremely well is it can feel when the sand is fluid-like and flowing, and when the sand is solidified. And based on that response, it can adjust its gait reactively. So as the Spirit is poking down, it can slow down and then trying to solidify the sand. And once it feels that solid ground underneath, it can start to push. And using this strategy will help Spirit to integrate the sensing data into its locomotion control and allowing it to cope with a wide variety of sand stiffness that we might see on the planetary surfaces. For planetary exploration, we have super expensive rovers. They can carry a lot of payload. But at the same time, the wheels are not necessarily the best suited for deformable sand or the rugged terrain. So having a leg scout can help the rover to plan its path informatively. What we imagine in the future is we'll have a group of legged robots running around and using their legs to feel where it might be soft sand pit that the rover might get entrapped. This information can be passed to the rover by the leg scout so that the wheel rover can navigate through the environment and make data collection with less risk of being stuck in the sand. Through the LASSIE Project, we are developing this telescoping arm that can extend and duck to enable different robots to connect to each other. So we envision that if there are unexpected failures that occurred, especially to the wheeled rover, we can actually have leg robot moving closer to it, anchor themselves in the sand, and literally land arm to connect to the rover and then collectively pull it out or push it out. So looking forward, we expect that from being humans' best friend on Earth, the robot dogs, Spirit and its friends will become humans' most reliable support in space to support human and other rover exploration on the moon and Mars and beyond.